Welcome back to PTD. We have to now focus on a new series that's under normalization. Um, we'll start with informal design guidelines for relational schemas, which are just some guidelines that we normally use to all other than using, we are going to follow this convention so that whenever we are normalizing in the future, we don't make any mistakes. That's the main idea behind informal design guidelines for relational schemas. So let's just dive right in. Informal design guidelines for relational schemas. These are these guidelines can be divided into mainly four guidelines. Okay, we have four guidelines. The first one is only one entity type, only one entity type, or relational type per relation. This can also be interpreted as entity type or relational type instance per tuple. This is the first and foremost guideline that we are going to use to whenever we are starting with dividing or decomposing big complex relations into small simple relations. And the second one, the second informal guideline that we are using is no anomalies. No anomalies, or we can say eliminating eliminating insertion, deletion, and modification anomalies. This is the second guideline, informal design guideline that we use for our relational schema anomalies. Third one is minimizing null values. This is the third guideline. And we have one more guideline, which is related to how can I say, a condition that we have to satisfy. Okay, so satisfy lossless join, lossless join condition. These are the four main guidelines that we are going to use so that it will be easy and perfect way to decompose tables or decompose relations. So let's start with the first guideline, which which actually tells us why one entity type or relational type per relation is good for our relations. The design that design is good for our relational schemas. Well, all these guidelines, before I jump into guideline one, all these guidelines have some responsibility. Okay, all these guidelines have some responsibility in three main advantages. Okay, so if you follow these guidelines, okay, if you follow these guidelines, the advantages will be, we will have some advantages, and these advantages will be ensuring clarity, ensures clarity, and then this will reduce data redundancy. This will reduce data redundancy, which means ultimately there will be no data inconsistency. Okay, redundancy, and also helps us to maintain data integrity. Data integrity means there are no the unoriginal data in the relations that we break into. Okay, so we can maintain data integrity. These are the main three advantages that we can obtain by following these guidelines. Okay, so let's look at the first guideline. The first guideline says only one entity type, only one entity type, or relation type per relation. Or I said you can say we can only have one entity type or relation type instance per tuple. Okay, so how can we understand this? Well, I have followed a main structure when teaching this. First of all, I will tell you the guideline. Second, I will introduce you to the real principle or what's the definition behind this. Okay, the definition or the real principle behind this. Okay, so here actually each tuple that we find in a relation, each tuple in the relation must be a single instance, must be a single instance of the entity or relationship instance. Okay, so this is what I mentioned earlier. So what are I will explain it step by step. Okay, so we have already studied. I mean, when you are coming to normalization section, you must have a prior knowledge on ER diagrams and EER diagrams. There we studied that entity is an independent object. Entity is an independent object. Entity is an independent object. Okay. And relationship is how entities interact with each other. Okay. So we can say interaction between entities. Okay. Interaction between entities. So we know ER diagram is the second step of creating a database. Second step of creating a database, which is just the conceptual design. So when you are converting the required requirements, the requirements that you have analyzed into a conceptual design like ER diagram or EER diagram, you make sure that each entity, okay, each entity is an object or logical idea, okay, a logical concept. For example, it can be a person, it can be a place, it can be an event like marriage, divorce, death, like that. So you make entity a single thing. Like for example, this will be an entity, employee. This can be an entity. Or you will have a relationship with someone. Okay. For example, in this relationship, let's say works. Works in which thing? He will work in a department. The employee will work in a department. So this is how you create the ER diagrams. So whenever you are converting from ER diagram to logical design or into a relation, okay, make sure that only one entity is represented by a relation. Only one entity or one relationship is represented by a relation. Don't put everything in and make the relation look bad. Don't make the relational schema structure poor. Okay, that's not good. That's why we are following the first guideline: one entity type or relation type per relation. So I can add on to this principle. We can apply this to individual relations. Apply to this guideline is applied to individual relations and their attributes and their attributes. Okay, I haven't introduced what is the purpose of attributes here. Okay, I will be explaining in few minutes. Okay, so what is the advantage of this principle? Well, this ensures clear and meaningful representation of data. Ensures clear and meaningful representation of data. Okay, some person who has no idea about databases can understand what's going on if you follow this guideline. Okay, so a non-technical person can actually understand if you follow this method. So meaningful representation of data. All right. So after the guideline, I introduce the principle. Now we are going to learn about the expectations or objectives, goals, whatever you want to say. I prefer the word expectations. So let's start with expectations of this specific guideline. All right. Let's start with the expectations with this specific guidelines. So what are the expectations? Well, so as the expectation must be a something that follows the guideline, okay, that defines the guideline. More than defining, it should be something that we should keep in mind whenever we are doing this normalization. Okay, so the guideline one expectation is a relation corresponds to a single logical concept. What are logical concepts here? Entity or relationship. Okay. Second expectation is each tuple in the relation, each tuple in the relation should be an instance of that logical concept, or we can say instance of primary concept. Employee, if you have an employee relation, and if you have a tuple about departments, well, that's not good. That's the why. That's what we are trying to avoid here. Okay, an instance of primary concept. And the second and third and important one, attributes in that relation should be the details of the relation. Attributes in the relation should be the details of the relation. Okay, we already know attributes or columns are properties of a relation, properties of an entity, properties of a relationship. So that's what we are doing here. Attributes that in that relation should be the details about primary concept. Or you can say the entity type or the relationship type. Okay, so these are the expectations. Now, let's learn how can we achieve these expectations one by one. We have three methods to achieve these expectations. So let's start with the first one, how to achieve. How to achieve. Well, the first one is relation to relation design. Relation to relation design. Relation to relation design. So as I already said, design the relation such that it corresponds to single logical concept. For example, if you have to represent employee, department, and all, first of all, use an employee relation. Okay, use employee relation. Also use a department relation separately, and finally use works on or employee department relationship type of relation. Okay, so this is relation to relation design. So in this concept, we have also in this method we have to also make sure that we don't force attributes that do not represent the primary concept. If you have the attributes about department and if you force it into employee, you are violating the first guideline. So make sure avoid forcing attributes avoid forcing attributes that do not relate to primary concept naturally. Okay. இப்போ டிபார்ட்மெண்ட் ஐடின்னு நீங்க வந்து யூஸ் பண்ணுவீங்களா இருந்தா, if you use department ID, in employee, well, that's a proper way to use the attribute. Why? Obviously, we have to know which department they are working. But in the employee relation, you don't need the department name. No, you don't. You don't need department name, or you don't need department contact number, or department head location. That they those are in department relation. Those are not to be mentioned in the employee relation. So keep that in mind. Okay. So keep that in mind. Avoid forcing attributes that do not relate to primary concept naturally. Now we have the second way to do this. Okay. Clear attribute semantics. Clear attribute semantics. This is actually a basic thing that every programmer must know. Okay. Whenever you are creating a variable, okay, whenever you are creating a variable, you should not create a confusing variable. The variable should be self-explanatory. Okay, it should be self-explanatory. So if someone who didn't involve in the programming sees the code, they should be able to understand from the code itself without comments. So similarly, in database, when you are giving attributes and attribute names, please make sure they are clear. Okay, so explain attributes should explain or should clearly indicate their purpose. Clearly indicate their purpose. Okay. Clearly indicate their purpose in the relation. Okay. The name should be self-explanatory and meaningful. Self-explanatory and meaningful. So this is the second step. How you can do, how you can follow the first guideline. And the third and last guideline is related to actually attributes only. Okay, it's related to actually attributes only. We shouldn't mix attributes of different entities. The first one also repeats here. So avoid mixing attributes. Avoid mixing attributes of different entities in a relation. Don't do this. Okay. So different entities, the attributes of different entities should be kept in different relation. Attributes of different entities must be stored in must be stored in distinct relation. Okay, they should be stored in distinct relation. That's very important idea that we should keep in mind. Always keep it in mind. Okay, and if you do not avoid mixing attributes of different entities in a relation, what happens is you will be facing with anomalies. Okay, anomalies will be caused if we do not follow this step. Anomalies will be caused if we do not follow this step. If we don't follow this step. So keep that in mind. If we don't follow this step, anomalies will be formed. The different types of anomalies: insertion, deletion, and modification anomalies. So this is the first guideline that we are using. Okay. So if we dive right into it, okay, here you can see an example. Okay, here this schema design. Okay, this schema design is very bad. Okay, I'll explain it to you one by one. First of all, the relation to relation design is not proper. Okay, why? They have one entity here. Okay, they have another entity here. They have another entity here. So they have three entities. They have three entities in a single relation. in a single relation. What are those entities? One, they have employee ID, employees. Okay, they have an entity about employee, and they have an entity about department here. Okay, about department here. Third one, they have a project entity also mixed up here. Okay, that's the first and foremost mistake. Okay, and the second one, well, the second one is okay. The attribute semantics is actually okay. The names are self-explanatory and meaningful. But the first step in the first thing that we focus is they should be explaining their purpose. Okay, project budget does not explain. It doesn't. Okay, uh, department name, it doesn't explain why is it here. Okay, we should have a department ID. Okay, that's how we should keep it. Okay, so that's the second issue. So the second one is partially covered in first guideline. In first guideline, the second step we perform is partially done. All right, and the third one is obviously wrong. Why? There will be modification anomalies. Okay, since there are only three tuples, you may not see this. But if you have more than three tuples, okay, let's say we have someone called John, and they are in HR department. Okay, and let's say they are working on project 01, and the project budget is 5,000. Okay, and let's say there is someone called Doe. Okay, and they are also HR, they are also working on project 01 and 5,000. Let's say we have to modify the project budget from 5,000 to 10,000. Well, now you will have to update three tuples here. Okay, instead of one tuple, you have to change three tuples here. And what if project one is finished? Okay, what if project one is finished? Will this become null? Will this become null? And if this become null, they can't have null values. So what happens is the entire tuple will be affected. Okay, so deletion anomaly, updation anomaly, even there are insertion anomalies. For example, that's the problem. If you have only the employee name and department name, and if they don't work on a project ID, there will be null values in the relation. So there are so many issues with this schema design. So what we can do is we can actually break this down into specific relations. Employee relation, see, in employee relation there are details about only employees, the employee name and which department they work on. And in department relation, the department ID and the department name. Okay, and then we have project ID and the project name and project budget. Now these three actually follow the first guideline. Okay, they are about one entity type. Okay, they are about one entity type, and their attributes are self-explanatory and they indicate their purpose in the relation. And the third one, there are no anomalies. Okay, there are no ways to form anomalies since there are not any attributes that do not explain or that do not relate with the primary concept. So therefore these three are good. Okay, so advantages of improved design. We these are actually how you do this, but this is how you can also see. But as I already said, you can say reduced redundancy, ensures clarity, and also it maintains the data integrity. These are some examples. Okay, and scalability. Okay, scalability. Why? If you change one here, that do not affect any of these relations, any of these entities. Okay, if you change something here, that won't affect these two entities. So that's why we use the guideline one. Okay, yeah. So keep that in mind. So that's why we follow guideline one entity type or relation type for one relation.
Thank you for joining this deep dive into Informal Design Guideline 1 for Relational Schema. If you enjoyed this video, give it a thumbs up and share it with your friends. Subscribe to the channel and hit the notification bell to stay updated with more videos in this series. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.